All right, so this is question 34 from your, again, the third practice test that I handed out. Just going over the different vernacular that describe switches. So this will be a bit of review, but let's just go over the four different types and what poles and throws refer to. So we should all be familiar with the single pole and single throw switch. So the pole indicates the current paths for that particular switch. So in this case here, we have one path for current going into the switch, and the throw, the throw indicates the positions that the actuator can connect to. So in this case, our actuator, which is that lever arm, can only connect to this point here. And so we have one throw. We have one way that the current can flow through this particular switch. And so we call that a single pole, single throw switch. Okay, so that is single pole, single throw. Now, if we go single pole, double throw, again, we're going to have one path for current. So that's our pole. But this time, we're going to have two positions that the actuator can turn to. So it can either be, we're going to have this one common that the actuator is going to pivot on, and it can be connected to that point there and that point there. Okay. So we got single pole, one path for current to flow, and we have a double throw because we got two positions that the actuator can contact. Single pole, double throw. And that's our classic three-way switch. Okay. Now we got a double pole, single throw switch, which is what we see above here. Okay, so for a double pole, we now have two paths that current can flow through into the switch. In this case, one is going to be moving in that direction and one is going to be moving out, most likely. Not in all configurations of the switch, but typically in electrical, we would see that. But we have two viable conductors going into the switch that current's going to travel on. Okay, so we got two poles. One pole, two pole. And then we have our actuators. But our actuators are actually mechanically linked. And so when you flip your switch, you'd only be looking at like a typical wall switch. You'd be able to flip it and it's going to close both of those actuators at the same time. They're going to make contact at the same time. So really, there's only one position for that actuator to be in. Either it's off, which isn't really a position, or it's on. Off or on, but they're controlled together. And so we call that double pole, single throw switch. And we would see that in like a 240 volt circuit. So we have 120 volt minus 120 volt coming in to like a motor or something like that if we have a 240 volt load. And so when we close it, it allows current to flow to the motor and then back into the supply. But because we're dealing with two hots rather than a neutral, a grounded conductor, then we have to, code says we have to open up both those live circuits. both those live conductors. Okay. Oops. Lastly, we have a double pole, double throw switch. So in that case here, we have, again, well, let me change up my color here. We have two current carrying conductors coming into the switch. And they're going to be mechanically linked. All right, so that's my two poles. So it's a double pole. But this time, we're going to have contact points. Two sets of contact points per pole. And so when we flip our switch, it can flip and make contact with one conductor. And when we switch it, both of these are then going to contact another set of conductors. And so you have two positions that are going to be viable options to send current to your particular downstream, to your load, or what have you. So this would be your double pole, double throw switch. Not very common in your typical house wiring or anything like that, but one that you might be tested on. So again, a pole refers to the number of circuits controlled by the switch. And a throw refers to the extreme position of the actuator. And so you got two positions for the actuator to sit on in this case. Double pole, or sorry, double throw. And then you have two paths for current coming into the switch. So double pole, double throw. Hopefully that clears it up. And so for the answer for this one here would be two positions for current to go into the switch. And then one throw, because there's one point the switch is not connected to anything. It only makes contact in one position here.